Okay, hello guys, welcome back to my channel. So today we are discussing a very interesting and popular interview puzzle. Okay, and the problem is called the wason selection task, and it uses the concepts of propositional logic from discrete maths. And let's get started. Okay, so here the question is like as follows. So what you have, you are the quality control technician working for card games manufacturer, and you have to ensure that whether all the cards follows this rule or not, that if a card has circle on one side, then it has the color yellow on the other side for sure. So you have, what you have to do, you know that for every card there is a shape on one side and on the back side there is a color, and you have to pick or check minimum number of cards out of these four cards. How many minimum cards you have to turn and check whether this rule is being followed or violated. Okay, so I hope you understood the question. So let us convert this problem into a mathematical equation. Okay, so first we will break down the compound statement into variables, propositional logic variables. Okay, the first variable would be the card has circle on one side. Okay, q would be the card has color yellow. The card has color yellow on one side. Right. On one side. Okay, so now let's convert this, the statement that we have to prove, in terms of propositional logic operators. Okay, now how do you understand, how do we convert this English statement into a propositional logic statement? Then what do we do? See how these two p and q variables are connected. If something happens, then the conclusions should definitely happen. Then which logical operator uh, helps you condense this situation? It is implication, right? P implies Q. So we have to check which of the options among the four cards we will have to check whether, in order to prove that P implies Q is always true. Okay, so let us write the truth table of P implies Q. Okay, let us quickly do that because there are two inputs. So there can be four possible values that these two variables can take. P, Q, P implies Q. Okay. 3 and 4. Okay. So 0, 0, 0, 1, 1, 0, 1, 1. This 0 means that Q, that the card has color yellow on one side, is not true. That means it has some other color. And Q1 means what the statement says, the card has color yellow on one side, is true. Okay. Now I know that P implies Q is false only in one case, when P happens and Q did not happen. So only in this place it would be a 0, otherwise it would be a 1. Okay. So let's check all the options one by one, whether we need to turn that card and see what's on the back side or not. Okay. So this is the case when the card does not have a circle on one side. That means P is false. So let us check in the table in which cases is P false. Only in two places we see P is false. But do we need to check these two cases of the truth table? No, we don't, cause it does not, no matter what is the value of Q is true or not, P implies Q is always going to be true. So we don't need to check this condition because our statement is because of P, Q should definitely happen. But P did not happen. So Q can or cannot happen. That does not violate or makes P implies Q false. Okay. Let us check the option number 2. So here P is true. That card has a circle on one side is true. That means in the truth table P would have a value of 1. Okay. Let us uh, change the color. Okay. So where does P has a value of 1? In these two columns of the truth table. Okay. So now see the value of Q. If this card we will have to turn. Why? Because see, for this row, if P is true, that means card has circle on one side, but Q is false. That means it does not have yellow color on the back side. Then P implies Q, this rule becomes false. So we need to turn this card and check whether yellow color is there or not on the back side. Let's check the third option. Do we need to turn this yellow color card? So we have the yellow color on one side. That means Q is true. Okay, we'll remove this. Try to write it again. Okay. So the rows or input combinations where Q is 1. Which are those options? Let's see. So Q is 1 at this row and this row. But in both the cases, whether P is 0 or 1, it does not matter. P implies Q does not violate, is not false. So we don't need to turn this card. The last option, that Q is false. So let us see the rows where the option Q is false. So over here, the ones I am marking with blue and here. Okay. But here note, if P is 1 and Q is 0, then this row is a problematic row. The P implies Q rules become false. So yes, we need to check this option also. We need to turn the red color card as well. Okay. So this is also a correct option. So we need to, the answer would be 2. We need to pick this card with a circle on it and the red color card to verify that this rule is never violated. Okay. So bye bye and take care.